Related to thermal conductivity analysis using finite difference method in MATLAB basically. Basically in this project we have just developed the modeling of heat condition of solid finite difference methods implementing in MATLAB, and we have used the complete discretization equations with the simulation of one-dimensional, two-dimensional steady state and transient heat transfer in materials with varying thermal conductivity. So basically, this approach is used to highlight the effectiveness of MATLAB in solving of partial differential equations and its role in validating theoretical heat transfer concepts. So I have just written the complete steady state based thermal conductivity analysis as a abstract, and then I have added the introduction of thermal conductivity with the discretization of partial differential equations, including one-dimensional, two-dimensional steady state finite analysis method, and this is basically the concept of finite element method. Okay, this figure is representing the concept of finite element method basically. So the objective is basically clearance that we just gain the multiple objectives. First of all, we get that one-dimensional, two-dimensional with the heat conduction in homogeneous with isotropic materials. And second one is we need to implement the steady state transient heat condition. Then we implemented the Newman Dirichlet and mixed with the temperature distribution over time. Also next we have demonstrated the flexibility and effectiveness of the solid state equations in MATLAB with the using of computational use for partial differential equation in thermal physics. So this is the understanding thermal conductivity, importance of thermal conductivity analysis, and this one is basically the distribution without heat generation in the finite difference method. So yes, in two-dimensional heat method. So the problem statement is here, mathematical approach which we using. These are the equations used for the complete governing heat conduction in the solid state. And this one is a finite discretization differences equations, boundary and initial conditions, algorithm implementation, and the MATLAB simulation. In the MATLAB simulation, basically I have concluded the temperature distribution with the different time span, okay, with the position and the temperature values. These are the temperature distribution with the 5000 seconds and steady state temperature distribution in 2D plate basically, and steady state temperature distribution with insulated boundaries. Then discussions added with the 1D transient analysis, 2D transient analysis, and the conclusion, and with the basically I have just concluded that how implicit and crank Nicholson schemes are implemented, what variable thermal properties we have used, complex geometric and boundary conditions, adaptive mesh refinement, and the coupled multi-physics simulation basically, okay, and GPU acceleration and parallel computing. So these are the references I have added in it. So basically this one is the thermal conductivity analysis. These are the MATLAB files. 4 MATLAB files we have used. I have added these MATLAB files in here basically. all the code is added in terms of steady state simulation. Basically, I have just added the code in terms of separate. Okay, see, this one is basically the steady state transient temperature distribution 2D plate. Then we run the second one. Basically, this one provides the finite difference method with 2D steady state heat conduction with insulated boundaries. Yes, this one of graph. Next one is temperature distribution with 5000. Okay, basically I think it's okay, just a second. Let me just yeah. I think now it will works. Yes, temperature distribution with the distribution analysis. Yes, this one. 1000 second, and next one is the temperature distribution with 5000. Let me just also change its name. I think the name, the problem is in name. Yes, this one. Now it will work. Yes. See the temperature distribution with the changes of time. Okay. So this concludes the complete project. So if you need to ask anything, you just call me. I will answer your questions. Okay. Thank you.